Hello and welcome back to Educator.com and welcome back to AP Calculus. So today we're going to be discussing the areas between curves. Let's jump right on in. Okay, so let's look at the following. We go ahead and work in blue today. So let's look at the following situation. So we have ourselves a little bit of a graph here. And then we have one graph. Let's go ahead and call this one f of x. And then we have another one, let's say something like that. And we'll just go ahead and call this one g of x. And let's pick an interval from a to b. So we've got this and that. The question is, how can I find excuse me, the area between f and g? So how can I find this area right here? Well, it's exactly what you think. Exactly what you think. So we'll say, well, the area under f of x is just this. It's just the integral, as you know, from a to b of f of x d of x. And let me go ahead and do that in red. So that takes care of everything underneath f of x. That's it. And let me go back to blue. And the area under g of x, well, that's just the integral from a to b of g of x dx. I'll go ahead and do this one in black. That is this region right here underneath g of x. So you know already for years and years and years now, this area is going to be the area of f minus the area of g, and that'll give me the area that I'm interested in, this portion right here. That's it. It's nice and simple. The area above minus the function of the area below. That's all. So let me go back to blue. Oh, I'm already in blue here. So since f of x is greater than or equal to g of x on all of the interval ab, the area the area between is the integral from a to b of f of x d of x minus the integral from a to b of g of x dx. Nice and straightforward. And of course, that's going to be equal to, I'll go ahead and put those integrals together. It's going to be the integral from a to b of f minus g dx. That's it. Generally, you're going to express it like this, f minus the g, and then as a practical matter, when you solve the integral, you're going to separate it out as integral of f minus the integral of g. Okay, so this is when, over the entire interval, f is above g. So upper function minus the lower function. That's essentially how it goes. So area equals the integral from a to b. We'll write upper, the upper function, minus the lower function, d of x, or whatever variable you happen to be integrating with respect to. Okay, now what if we have the following situation? Where over a given interval, they actually cross. What if we have the following situation? Okay, so now we've got, we'll call this one f of x, and then we can do something like this. We'll call this one g of x. Well, now let's go ahead and call this a. So we've got that one. And let's go ahead and call, that's fine, we'll just put b over here. Something like that. So now where they meet, I'm going to go ahead and call this C. So the area between the curves is going to be this area right here. This area and that area. However, from A to C, it's F that's on top, and it's G that's lower. But from C all the way to B, now I have G is on top, and F is the one that's lower, where we find the area by taking the upper function minus the lower function. So you have to split this up into two integrals. You have to integrate from A to C, doing F minus G, and then you have to do the integral from C to B of G minus F. That is all. It's that simple. You just add the integrals together. You just have to separate them, and you have to find out where they meet, of course, to find that x value. And how do you do that? Well, you set the two functions equal to each other, and you solve for x. That's it. So let's go ahead and write this out. So on the interval AC, f is greater than or equal to g, so the area is actually equal to the integral from a to c of f minus g dx. And then, of course, from c to b, from here to here, in this particular case, now it's g that's greater than or equal to f. So the area equals the area from c to b of g minus f dx. That's it. Upper minus lower. That's all you really have to know. So we'll say that's all. Okay. So whichever graph, whichever graph is higher, up, on a given interval, is the first entry. The first entry is the upper graph. Entry in the integrand. There you go. The integrand is the thing that's underneath the integral sign. That's the integrand. Okay, because, and this is so, because we want the integrand to be positive, because we're dealing with areas, to be positive. There we go. That's it. Nice and simple. Okay. Now,